Good afternoon. My name is Nhlanhla Lucky Nkosi. Often when I'm asked what I do, I sometimes struggle to answer this question. And that's primarily because I wear a number of hats for a number of different organizations. But primarily, I am a software engineer for a company called BBD. Sorry, just a second. Do you want to update something? Okay, no. Looks like we're good. I primarily work as a software developer for a company called BBD. We are a bespoke software solutions firm. It's a firm that was started by 3 engineers 39 years ago in Sandra's garage somewhere in Johannesburg, and has now grown to be a global solutions or global IT solutions firm with over 1,000 engineers spread all over the world. We deliver software solutions into a number of sectors, from your banking, telco, the public sector, all the way into gaming. You name it, we probably deliver some software solutions into it. But my job at BBD is slightly different from everyone else's because I work in a unit known as ATC. We are, on paper, responsible for BBD's research and development functions. We do what we call specialized consulting, which is basically just trying to put out fires wherever they exist. But the most fulfilling part of what we do, rather, is that we are also responsible for facilitating learning or providing training to BBD's employees all over the world, which includes running graduate programs, internship programs, and we also get to go and talk to university students all over the country. For my sins, I studied engineering at WITS, where I got a degree in game design. And as their new slogan says, I just can't seem to leave it. I've gone back to lecture, and I am in theory registered for a master's degree that's meant to conclude this year. Whether that'll happen, we shall see. But everything I've told you about myself, none of it matters. The most important thing for all of you to know about me is that my Twitter handle is at Nhlanhla_Nkosi. Please feel free to tweet me and let me know what you think of this talk. Let's get into it. I'm getting old, and everyone around me takes pleasure in reminding me that I am getting old. So to try and prepare for this brand new age, I decided that I should probably start going to the gym. And the big problem with the gym is that it's a very intimidating space. From the people you see there to the equipment that you see there, I realized that this is just not for me. And so I decided to go back to keeping fit with the things that I actually enjoy. Sports. 2 sports in particular, horse riding and soccer. Not like that, more like this. So I play 2 sports, one that's known for people pretending to get injured a lot, and one where people actually get injured a lot. And out of these 2 sports, I sustained a really, really bad knee injury a couple of months ago from playing soccer out of all of them. So I've jumped 1.2 meters on a horse, but soccer happens to be the one thing that causes a really bad injury. And something really interesting happened when I got injured. I started getting very grumpy. Nope, not because my colleagues were consistently pretending to have tested their code when they didn't, but because I started realizing just how badly designed the world around me is for people with accessibility needs. One of the things that I absolutely hated was the shopping mall. And one of the big problems that I had with malls is that they have signs of what stores you can find inside by different entrances of the mall. So I needed a pharmacy. I saw a specific pharmacy name. I'm not sure if I can mention it. And so I parked right next to that entrance, thinking that the shop was right there. When I entered, I saw a sign with that shop right at the entrance. I ended up walking more than 600 meters just to get to that shopping mall. I was frustrated, I was in pain, and I started thinking, this is a temporary problem for me. How do people that live with disabilities on a permanent basis actually deal with these things? I saw a couple of ramps, which made for very interesting experiences. I don't know if you've ever tried going down a ramp on crutches. It's not a very nice experience, right? And some of these ramps, I have no idea how people that use wheelchairs are actually able to navigate them because the steep is just so ridiculous. I was frustrated, and I was trying to figure out who the best person to blame for this is. Is it the property developer? Is it the architect? And I started thinking, in our space, who is responsible for making sure that the solutions we deliver into industry are actually accessible to as many people as possible? I struggled to find the answer, and I realized that for me to get to an answer, the first step would probably to have a definition as to what accessibility is. So in my title, you would have seen A11Y, pronounced Ali. That is a numeronym. I think that's how you say it. So the 11 is simply the 11 characters between A and Y. You would have seen somewhere in your project, when you look at your configuration file, there's probably a file called I18N that stands for internationalization. Wow, what a long word. And again, 18 is simply for the many characters. So developers have decided it's too difficult to say, we'll just put a number and people will figure out what it is. The dictionaries sort of converge to this definition of accessibility, and they say it is the quality of being easily reached, entered, or used by people who have disabilities. So you'll see that this tries to cover quite a broad range of things. If we bring it closer towards what we're concerned about specifically, the World Wide Web Consortium, which creates standards for the web, describes web accessibility as meaning that websites, tools, and technologies are designed and developed so that people with disabilities can use them. They go on to specify that it is such that people can perceive, understand, navigate, and interact with the web. Quite an important thing to think about, considering that most of the solutions we build for people end up on the web nowadays. And so to answer the question of whose responsibility is it, I think the question goes quite similar to whose responsibility is it to make sure that the checkout button works. It's absolutely everyone that's involved in the SDLC. From your product owners, your project managers, your testers, your developers, absolutely everyone's job is to make sure that what we build works. We agreed that it works on my machine is not sufficient. It has to work on everyone's machine, and it has to work for everyone else. So it baffles me why we're comfortable to ship solutions that don't work for some parts of the population or for some part of our customers. And every time I've gotten into conversations about accessibility, I've realized that people see this as doing a favor to people that have digital accessibility needs. However, there's business impact to this. If you consider the fact that about 15% of the world has digital accessibility needs, this impacts the bottom line. Can you imagine what losing 15% of Amazon's revenue looks like? Imagine that money coming to your own pocket, right? That's how much of your customer base you stand to lose if you don't address accessibility concerns. Even more pertinent, these things are becoming legal requirements across the world. We're seeing government adopting regulations to make sure that all the systems that they put out into the world are accessible. 10 years ago, people could opt into using your technology. That's no longer a reality. Since COVID, more and more people are being forced to use technology and cannot opt out of it. And so this becomes very important. And a number of these regulations all converge towards seeing the WCAG or WCAG as a good standard to measure accessibility conformity against. Now, the WCAG is a set of technical guidelines for making web content more accessible to people that live with disabilities. It's effectively about 13 guidelines that's spread up into 4 categories that are aimed at making sure that everything we put out onto the web is perceivable, operable, understandable, and robust. Having guidelines is not enough. It also provides a way for us to measure just how accessible what we put out onto the web is. And there's 3 levels of conformity. Again, developers aren't the best at naming things, so we've named it A, AA, and AAA for good, gooder, and goodest. And the issues that each of these levels address range from simple things that have to do with the code, like making sure that all your images have alternative text, making sure that we can navigate it with a keyboard, all the way to looking at color contrast and even nuanced things like the language that we use in our content. Is it understandable? Or do we use big, difficult words to say like onomatopoeia? But if you look at what the most common challenges that people with disabilities face are, a lot of these are easily preventable. Things like the lack of alternative text, having inaccessible forms. I mean, a former colleague of mine used to say that all we really do is just shovel data. We build a form, users capture it, we shovel it to a backend, we sort of build these really intricate backend systems, and all they do really is shovel the data to a database, and then we shovel it back to the user. And so forms become a very important part of what we do. Things like color contrasting. Again, it's quite ironic with what's happening with my monitor. All the way to things like having a lack of keyboard accessibility. And again, this is not nice to have. Research has shown that things like shortcuts or keyboard shortcuts can improve people's performance quite significantly. And research has repeatedly shown that when you address accessibility issues, you generally create an overall better experience for all of your users. I recently had a conversation with one of the senior directors in our business about accessibility, and he told me a story about how we once hired someone that was blind to test a solution for one of our public clients. He told me about how this client very quickly lost interest in this initiative because they felt that this process was interfering with the speed at which we can deliver. I mean, it's easy to just deliver without testing things, right? And this client in particular decided to drop this entire initiative because it was just too tedious. This made me realize something. They had taken such a big responsibility and made it one person's problem. Everyone else tried to continue what they were doing. They would pass on all of the work that they produce, and this one person had the burden of making sure that they gatekeep the quality of the software that they were delivering. This is not on. So I then realized that for us to start, we cannot just keep saying this is a difficult thing, we have no idea how to do it. We need to find the necessary tools that are going to enable people to firstly learn and to implement all of these things. These tools have to help people realize quickly what the problems are, how to solve them, and why they're taking those steps to go about solving them. So the crux of this talk really is to give you tools for everyone that's involved in software on how to go about testing accessibility problems and how we can go about automating some of these things. Off the bat, I'll start with my favorite people. I say favorite because nowadays I don't write a lot of production code. And these are the manual testers. They've been called QA developers, QA engineers. There are very many titles. But these are the people that make sure that we developers don't lie. Now, I'm not saying developers lie a lot. I'm saying we forget to do things a lot. I found over 100 tools that you can use to manually test accessibility issues. So there's absolutely no excuse. This website by the W3C has filters on the left-hand side that's able to tell you which tools address the concern that you are specifically interested in. So if you're looking at the WCA G2 guidelines or legal requirements, you can choose which country you're targeting, and it'll show you which tool is best for you to use. So in a nutshell, this talk is effectively a list of my favorite tools that actually make me productive when I'm testing for accessibility things. To do this, we need a website to test with. I considered using a number of websites, and then I realized that I don't actually want to make any enemies. And so I found this website that was built by the Chrome dev team, so the DevRel team there. And what this website is that it is the live website. So it's called Medical Mysteries Club. And they put a disclaimer there. I don't know if it's true or not, but they say that they deliberately made it inaccessible so that we can test on it. Well, either way, it creates a good candidate, or it becomes a good candidate for us to use. So the first tool, since we're talking about Chrome already, might not be new to a lot of you. So this is Chrome's developer tools, which comes shipped with every single Chrome browser out there. I'm sure Firefox does, in fact, have an equivalent. But in here, there's a tool called Lighthouse. Now, Lighthouse has this giant blue button that says Analyze Page Load, and when you click on it, it'll run an audit on your website. Lighthouse does a number of things. It can run an analysis report on your performance, on your search engine optimization. It'll also tell you just how good or bad your progressive web app is. There's a number of things that it can do. You can also look at what it scores on a mobile versus a desktop experience. It's really cool because it gives you a score. It then categorizes all the problems that it found via these categories. So you see here, it talks about area, which is what screen readers use to explain the content on your page. It then talks about things like names, labels, contrast issues, and if you click on any of those, it'll also highlight which element on your screen is actually causing the problem that it has found. Another thing that it does here is that it also guides you on what things you should probably check manually. And you'll see that the first one here says that the page, you need to make sure that the page has a logical tab order. Because if you don't have a mouse and you can only tab through the stuff, it must make sense, right? The same with people who can't see. The screen readers will explain the things in the order that you have actually given them there. It also then tells you what audits you've passed, which ones don't apply to you, and right at the bottom, it gives you the conditions under which you ran this test, so that when developers say, I can't reproduce this bug, it works on my machine. You can simply give them this, and they must prove to you that they ran it under the same conditions. So that's great, but this is not my favorite tool. On my favorite tools, you get as an add-on, it's called Wave. Wave stands for Web Accessibility Evaluation Tool. I don't know where they got Wave from, because that would be weight. But nonetheless, Wave is a tool. It's an add-on that you get from the add-on store, marketplace store. I forgot what we call it for browsers. But effectively, Web gives you the same type of things, but it also annotates your actual page so that you can see where these problems are. And if you click on one of these problems, say this about one, it tells us that the problem here is that there's a very low contrast. I'll read it for you because it might be a bit challenging with this overlay. You can see the code at the bottom of the screen that's violating this principle. And when you click on reference, it's able to explain to you what this means, why it matters, and it also provides a link to the actual specification that guides how this thing should be done. It also has a tab that actually goes and annotates your tab order. So while Lighthouse told you that you should probably look at this thing, Wave actually highlights. And you'll see here that the first thing is actually at the bottom of the page. I would have expected the first tab thing to be our logo here so that I can navigate home. But nonetheless, this becomes a really cool tool for that. It also then has a contrast checker, which is quite interesting to see here. And one of the cool things with this contrast checker is that here it tells you which of the validations you pass and which one you fail. So it tells us that the text fails on AA, and since we have a gray, I can simply change that gray just a little bit more to get to the nearest color that matches what I want, but is still accessible, which means that we can really get to building accessible things without compromising our design and what we actually want to go for. So going back to our slides, we spoke about Lighthouse very, very briefly, and we spoke about Wave. The third tool that I want to talk about is something called X DevTools. X is built by DQ Systems. They're really, really great. And what X looks like is this. It's also an add-on that you go and download. You also start a scan, and once you run that scan, it provides the results for you similar to the way that Lighthouse does. The only reason I'm not showing you this as a live demo is because it is behind a paid subscription, and I had exhausted my free trial by the time I started preparing my slides. However, DQ as a source of tooling is absolutely incredible. And so if you've got a mission-critical enterprise-grade system, I would strongly recommend that you explore their tools. We've looked at how to do this manually. Now, let's look at my second favorite people, the project managers. When I have to play the role of product owner or project manager during Project Rescue, I generally don't want to be fiddling around clicking things. It's always nice to be able to get a full holistic view, either in the form of a dashboard or a report. And so I'd like to introduce you to my friend called Pally, your automated accessibility testing pal. Now, Pally is a tool that you can install into your terminal. You can run Pally once you've installed it globally. You literally just type Pally in your console, give it the URL that you want to test, and it'll tell you all of those problems. Alternatively, you can also build your own application and actually use Pally over there. What that actually looks like is this. I'm going to zoom this in, and I'm hoping that you can see on the projector. So I've got Peli installed. Give me a website. Don't say my company. So HTTPS, let's use example.com. It's always a great example to use. You'll see that it says, welcome to Peli, and it ran the test on Peli. And over here at the bottom, it's telling us what problems it found on Peli without us actually needing to spin up anything on our machines. So already from our console, we are able to test our application. Now, in my experience of working with product owners, I know that the console can be a very terrifying thing. So this is not necessarily the best way to go about it. And so the second way of running with Peli is that we can really, really customize our experience. We can plug Peli into existing tooling and capabilities that we have. What I've built here is a simple Node.js server. It's using Express, which is probably the most common tool to use in the node space. It's got a URL that takes in, or it's got an endpoint rather, that takes in a URL, and we can then perform accessibility testing on that destination. What I've also got is that I've got this website that I've built here, and this website I built in vanilla HTML, CSS, and JavaScript because I didn't want to get into flame wars about which front-end framework is better. Nonetheless, we've got this very simple web page, and if I run yarn start, and you could do this with npm or npx or any tool of your choice, I should probably run yarn stop first. This is why you don't prep just before your talk, right? So is it running? Did it run? Yarn start. Let's see. So it's running, and it's saying that it is listening. And now what happens is that if I open, or if I click on this link rather, it went and tested google.com. That's not very accessible either, or very useful. And so if I use the website that I have just built over here, we now have this web page. I'm going to zoom in just a little bit so that you can see it slightly better. And in here, I can choose any website. So we'll go to that CodePen website we were looking at. If I click on it, it'll go and analyze that page. And then in just a couple of seconds, it can tell us all the problems that are wrong with that. So you can already start seeing the potential of us really customizing this experience and watching our entire system. In fact, we can look at our entire enterprise's systems to make sure that we are keeping up with releases. We could schedule these. We could make sure that these run after every single release as well. So while that is cool, it is not enough. Because at this point, I started thinking, if I'm building something this useful, I'm probably making a mistake. Someone has probably built this before. And so I found something called a Peli dashboard, which lets you keep track of a couple of links, but you can click on it and then go and run accessibility tests, so you don't manually have to keep entering these things. But with Peli as the core tools, you're able to go and build a fully customized experience. However, if the only time you actually track your accessibility issues is once they're in production, you're already too late. What we need to do is integrate this testing into the development workflow. We know that developers are not used to testing, are not new to testing rather. We know that they test all the time, but as an engineer, I know that sometimes I forget to run my tests and the stuff just, mistakes happen, or I'll run the test, it'll work on my machine, gets to production, and then it just doesn't work. The best way to make sure that your developers conform to the standards that you set is to actually block their code from making it into production if they fail these tests. And so what we need to do is we need to be able to run these tests in our console as part of our continuous integration pipeline. And if they fail, we block their pull requests and we guide them on how to go about fixing those things. So if your workflow looks a bit like this, where your developers make some changes, they push changes to a server, they request to merge them, and someone approves, we need to integrate that last step where we actually run those tests before that. So if you saw what I did, I started up a server while I was testing. I launched a browser. In the URL, I went localhost blah, 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 blah. I don't know why they gave me a chicken for that icon. AI is going to take over our jobs. But nonetheless, we've got localhost, and we wait for it to load, and then once it's loaded, we run Peli. The only problem with this is that Peli is designed to work on one URL. I don't know about you, but the systems that I often work on have multiple URLs. And so we need something slightly better. Peli has an add-on thing called Peli CI that's specifically designed for continuous integration platforms. Now, there's a number of them out there, whether you're using Travis CI, whether you're using GitHub DevOps. And so the one that I decided to talk to you about today is called GitHub Actions. And the only reason I chose this one is because, well, most developers have a GitHub account. So it's easy to get started and playing around with GitHub Actions. What GitHub Actions is that, or to get GitHub Actions working, in your project, you would need to have a .github folder, have a subdirectory called workflows, and a file that looks like this. So this is written in what's called YAML. I believe YAML stands for yet another markup language. I might be wrong. But what it is that in this file, we've given it a name, and we have triggers. These triggers say that when code is pushed to the main branch, or when there's a pull request to the main branch, trigger this thing. And what we're triggering, or this job rather, simply uses a couple of dependencies, which is just to check out our code, to use the latest version of Chrome, and then it uses this thing called Peli Actions, which again just starts up the server for us, so we don't have to do that work ourselves. It starts up our server on localhost, and it runs our CI test. That is it. So just by adding this file into our code base, what actually ends up happening is something that looks like this. I'm hoping that I'm going to go to the correct browser. Yes, I do. And so if we look at our pull request here, I created a pull request this morning, and when you look at the pull request, the merge button has now been disabled. It's been disabled because the checks have failed. So if a developer tried to push new changes to your code base that actually doesn't pass your accessibility test, or if they've broken accessibility on your website, they can no longer actually click merge. And over here, when they try to see what actually went wrong, it doesn't only tell them that it broke on accessibility, but it actually tells them exactly what went wrong. It tells them what the problem is. It tells them where the element is using a format that they're familiar with. It also gives them context, because if a label is broken, there could be multiple labels on our web page. This thing tells you exactly which label is not accessible, helping your developer get to fixing the problem quite quickly. So with GitHub Actions, we are testing an entire web page. But if you're working in a large enterprise system, you're probably not making changes to a whole page. You're probably changing a small component that's going to be rendered on a whole page, which means that we need to get even more granular to that. So a general web testing environment will consist of a test runner. Examples for that are things like Mocha and Jasmine, an assertion library like Chai, and the last thing is a headless Chrome. I've been using the Chrome browser quite a lot. That's because we're testing things that actually end up getting rendered onto a screen. And for that, we can use something like Puppeteer. This sounds like a lot of tooling, but we can simplify it and use something like Jest, which sits squarely across both those lines. Jest is probably the most popular testing framework there. The website claims that it's delightful. I don't know if anything in the web is delightful, but they say Jest is a delightful testing framework with a focus on simplicity. For those of you that love Vue or Angular or React, this thing works with all of your favorite tools. It's a nice, simple library. If you have a function like a sum, you can write tests that describe what you expect. So you say, we expect the sum of 1 and 2 to be equal to 6. And if what you expected versus what it received doesn't match, it simply tells you that it's wrong. We can then extend this by adding on X, which I spoke about earlier, about it being behind a paywall. Only the added features are. The core library itself is available for free. And so using something like Jest with X, we are now able to test just the component. So if you look at my screen, I have a div with an image. That image doesn't have a script tag or an alternative text rather. And if I were to run tests on that, it would very quickly tell me that it expected the div not to have any issues. But in red, I'm hoping you can see red, it says that all page content should be contained by landmarks. And that's the rule that we violated, because we have a div that doesn't exist within a page. But if we're building a small component, it can't exist within a page because it'll only be on a page once it's done being rendered. And so we can configure this X tool so that when we actually write it, it understands our context. This is cool and all, but as a developer, I've been very frustrated by making a whole bunch of code changes, and only when I try to actually deploy, the thing actually breaks. And so we can get even one step closer to that and use a linter. This is an accessibility linter that coaches the developer while they build your application. So if you look at that image tag there, I created an image without an alt text. It created a red squiggly line, and when you hover on it, it's able to tell you and coach you on what is actually going wrong. I spoke to one of our senior developers about this, actually someone from my infrastructure team, and he said, what you're going to have is a lot of developers pushing their code up and using up all of our build agents just to tell them that your stuff is not accessible. You're going to cost us resources in our build server. And so we can actually intercept that and run these tests locally on their machine by using something called Husky. So Husky uses Git hooks. So when your developer tries to commit changes to their local repository, Husky can run a list of scripts that you want it to run. One of them could be your accessibility testing tools, and it will actually block them from committing to their own local machine. So you're intercepting accessibility testing quite early on. They might get frustrated by this in the beginning, but you very quickly create a culture of thinking about these things. I've said a lot of things. I've said a lot of things very, very fast. And so I'm going to summarize all of them in one slide. Accessibility is important. We can build dashboards that help us monitor how accessible our websites are. If we're migrating an old system, we can keep track of what has been done, or of what has been addressed and what has not been addressed. We can use Peli with Node to build our own custom dashboard. For manual testing, we've got Lighthouse that's built into everyone's Chrome browser. We can use Xtools if we have money. We can use Wave to see a comprehensive result. We can automate a lot of this testing by gatekeeping our main or release branches using Peli CI. We can test at a component level using something like JustX. We can use Husky with Git hooks to make sure that no code leaves a developer's machine unless it's absolutely accessible. And we can configure what all of these standards mean for our context. I've often found that designers are the first source of this problem. They also don't have an excuse, because a lot of their tools like Figma also have plugins that help them deal with these accessibility issues. This one helps you see what the code or what the screen will look like for people with varying color blindness. There's a contrast checker that's able to tell you which standards you pass and which standards you fail. Microsoft Design has a plugin dedicated to dealing with navigation and your focus order. eBay has one for landmarks. And of course, DQ has X, which is all-encompassing. What this means is that you can have your designers, your product ownership team, your developers, and your testers all using the same language to describe what the problems are. And this is likely to stop you from having accessibility issues. We can integrate accessibility testing into all of these parts. I would be amiss. I wouldn't be doing you justice if I didn't caution you, though. This does not solve all of your accessibility problems. It has limitations. Generally, the ecosystem can check about 30 to 40% of your accessibility problems. However, DQ claims that they can capture up to 57% of accessibility problems out there. So yes, we're getting better. But there's also a chance for false positives, false negatives. And the lack of context means that you need to configure these tools to work for your scenario. I'll close off by quoting a modern philosopher, ChatGPT, who says, it's important to remember that automated testing should be used in conjunction with manual testing and user testing to ensure the highest level of accessibility. So if there's one thing that you do when you walk away from this talk, I hope that you start thinking about what you're doing in your space to make sure that the solutions you build are accessible to as many people as possible. My name is Lucky Nkosi. Thank you very much.